Alkanes are organic compounds that consist of single-bonded carbon and hydrogen atoms. The formula for alkanes is CnH2n+2. Alkane as saturated hydrocarbons. Alkanes are a series of compounds that contain carbon and hydrogen atoms with single covalent bonds. These are known as saturated hydrocarbons. This group of compounds consists of carbon and hydrogen atoms with single covalent bonds, also comprises a homologous series having a molecular formula of CnH2n+2. Alkanes are the simplest family of hydrocarbons. They contain only carbon and hydrogen. Chemists use line-angle formulas because they are easier and faster to draw than condensed structural formulas. Structural formulas for alkanes can be written in yet another condensed form. The simple alkane methane contains one carbon atom and CH4 as its molecular formula. As this compound have just single covalent bonds only, therefore, its structural formula is in a long-chain alkane molecule, additional carbon atoms are attached to each other with the help of a single covalent bond. Each atom is attached to the sufficient hydrogen atoms to develop a total of 4 single covalent bonds. This long-chain structure is known as octane. An 8-carbon alkane has a molecular formula, C8H18, and structural formula. List of alkanes and its structures. The list of some alkanes with molecular formulas and structures. Physical properties of alkanes. The solubility of alkanes. Due to very little difference of electronegativity between carbon and hydrogen and covalent nature of CZ bond or CH bond, alkanes are generally nonpolar molecules. So we generally observe polar molecules are soluble in polar solvents, whereas nonpolar molecules are soluble in nonpolar solvents. Hence, alkanes are hydrophobic in nature, that is, alkanes are insoluble in water. However, they are soluble in organic solvents as the energy required to overcome the existing van der Waals forces and generate new van der Waals forces is quite comparable. The boiling point of alkanes. As the intermolecular van der Waals forces increase with the increase of the molecular size or the surface area of the molecule we observe, the boiling point of alkanes increases with increasing molecular weight. 3. The melting point of alkanes. The melting point of alkanes follow the same trend as their boiling point, that is, it increases with increase in molecular weight. This is attributed to the fact that higher alkanes are solids and it's difficult to overcome intermolecular forces of attraction between them. It is generally observed that even-numbered alkanes have a higher trend in melting point in comparison to odd-numbered alkanes, as the even-numbered alkanes pack well in the solid phase, forming a well-organized structure which is difficult to break.